Alright guys, today we're going to be talking about medical math. So let's kind of do a sideline here real fast, and let's talk about phonics versus sight words, because these are kind of two approaches people take to reading, and they do the same approach when it comes to math. So when you learn to read through phonics, you sound out your words. Ra, a, t, da, a, g, s, e, k, right? And that's a lot more work up front than using sight words. Rat, it is because it is. Dog, it is because it is. Sink, it is because it is, right? So now the question isn't how hard is it to learn, doing your reading this way, but how helpful is it to learn to read that way? So looking at that same set of words, right? Rat, dog, sink. If you learn to read through phonics, here's just a small list of all the words out of nowhere you can read, right? Rats, sat, dog, dot, writ, dit, rot, tod, god, got, gat, gad, gar, gas, gan, gack, rink, rog, and so on, right? And I could go on, right? This was just a short list of those words right there. All right, now with the sight word method, here's a complete list of all the words that you can now read. Rat, dog, and sink. And hopefully you don't forget your shortcut. That rat says rat, it is because it is. And dog says dog, it is because it is. And sink says sink, it is because it is. The problem with the shortcut method of learning how to read, just sight words, is the average adult knows about 27,000 words. So are you going to try to memorize 27,000 random words and hope that you don't forget a shortcut? Not going to work out so well. Well, a lot of people take the same approach for math. And so instead of learning how to sound out your math using the phonics of math, they use the shortcut method and they get the exact same results. So they learn one shortcut, they can do one math problem. They learn another shortcut, they can do another math problem. They learn a third shortcut, they can use as a third math problem. And they never get ahead with their math. Now, if you insist on learning it the shortcut method, these are some great links to it. And you look at this, we got 11 different links here, right? Why so many? Well, what happens is each link has to teach you a different shortcut for a slightly different problem. So, if you're having to do, for example, a math problem that involves grams, you need a different shortcut. If you have to do a math problem that involves milliliters, you have to do a different shortcut. If you have one that's doing pills, different shortcut. Insulin, different shortcut. Heparin, different shortcut. If you want to know how long an IV is going to take you, different shortcut. And so really, I'm not a big fan of the shortcut method. Why? Because you have to know a never-ending supply of shortcuts. And so hopefully you can remember the right shortcut for the right problem, and hopefully you can remember what the right units are. There's just a whole lot of hopefulness here and a whole lot of things you have to memorize, right? And so what I like to do is teach students the phonics of math, right? It may seem like a whole bunch of work at first, but really it's the easiest way possible. Teaching a child to read, at first it seems like a whole bunch of work to teach them how to say cat, right? C says k, but it also says s. A says ah, but it also says a, and sometimes it says ah, but also when it's with other vowels, sometimes it doesn't say anything. And then T says t, right? Well, why not just teach them that it says cat, right? Wouldn't that be a lot easier? In the short run, yes. If that's the only word in the English language, oh my goodness, what an absolute waste of time it would be to teach them what all those letters said and why they would say those things. But the problem is there's more than just one word in the English alphabet. There's easily 50,000 words that you can say and use on a fairly often basis, right? And so if I teach you how to read through phonics, in the time it takes you to learn 150 rules, you will have learned 45,000 words. because you're able to apply those 150 rules. Now, if you use the shortcut method, in the time you've learned those 150 words, you've learned 150 words. And if any of those words change ever so slightly, you're doomed. Yeah, it just doesn't seem anywhere near as effective, right? And it's the same thing with this math. It takes a little bit longer to learn how to do a math problem this way, right? You can learn a shortcut faster than what you can learn what I'm teaching you. But the problem is you've learned just to do one very, very cookie cutter math problem. Unfortunately, life isn't cookie cutter, right? And then on top of that, if the problem changes ever so slightly, you're doomed. And so I really am trying to help you out here by teaching you how to sound out your math. So if you're really sure you got it with the shortcut method, put yourself to the test. Go look at the next slide and see whether or not you have it down, right? You need to be able to answer all of those questions correctly. If you can't do it, your shortcuts are failing you, all right? And so definitely pay attention to the phonics approach to math that I'm teaching you. So let's see how well you got your math down. So Susie weighs 20 kilograms and she's supposed to be getting 15 milligrams of Tylenol per kilogram that she weighs in every single dose that she gets. She gets one dose every 8 hours. In Tylenol comes a solution that has 160 milligrams of Tylenol for every 5 milliliters of solution. Is Susie supposed to get her entire dose of Tylenol within 10 minutes? How fast should you set the IV for in terms of milliliters per hour? If there are 60 drops in a milliliter, how many drops per minute would her IV be running at? And how much time will there be between drops? Alright, so pause the video, and when you think you have your answers, take a look at the next slide and see how you did. So let's see how you did. So what you should have gotten is the IV was set at 56.25 milliliters per hour. That's what your calculator is giving you. And that, the drop rate is going to be 56.25 drops per minute. And then it's going to be 1.07 seconds between drops. Now, you're going to have to use a little bit of common sense here, right? The IV fluids, the machine isn't going to let you drop at 56.25 milliliters an hour. And so you're going to have to round that to the nearest whole number. And so that would be 56, right? Remember, if the number is 5, is less than 5, you're going to round down. If it's greater than 5, round up. Well, what happens if it's exactly 5? Then you round to the nearest even number. Alright, now if you had trouble getting any or all of these answers, then you're definitely going to brush up on this factor label method. So definitely pay attention to the next couple of slides. I will have timestamps down below, and so if you already get an idea, you're not going to have to go over multiple examples of something you already understand. So definitely make sure that you're using and taking full advantage of those timestamps in the table of contents to skip ahead of stuff that you already know. So, alright. Use this information to answer the questions below. Joanna weighs 44 pounds and she's supposed to be getting 20 milliliters of IV fluid for every kilogram that she weighs. If Joanna is supposed to be getting her IV fluids within 15 minutes, how fast should you set the IV for? If there are 25 drops in a milliliter, how many drops per minute will her IV be running at? How much time will there be between drops? If her IV started at 0:36 hours, at what time will she be done with her bolus? If she's supposed to be getting 60 milliliters of IV fluid per hour as maintenance on top of what she's getting as a bolus, how fast will you set the IV for the first 15 minutes? At what time will she finish her first liter of IV fluids? At what time will she finish her second liter of IV fluids? And so take some time to pause, answer these questions, and if when you finish these questions, or let's say you got stalled and like, oh my goodness, there's no way I can figure this out, you definitely want to pay attention to the next couple of slides, because I'm really going to go into the phonics of math. It may seem like for some of you, I'm taking you a step backwards, but I'm going to take you a step backwards so we can take you a great leap forward. Because the never-ending series of shortcut method, it just never stops, and you never fully get a good grasp of math. If the problem changes by a hair, you're up a creek without a paddle. Alright, so here are the answers. So how fast will you set the IV for her to get that entire bolus, not the maintenance fluids added, just the bolus, within 15 minutes? Well, you're going to set it at 1,600 milliliters an hour. Alright, how many drops will that be per minute? That will be 667 drops per minute. How many seconds will it be between drops? 0.09 seconds per drop. So here's a little bit of common sense here. What you're going to do is, obviously, we're not going to be able to count that level of detail. So, my common sense is going to be able to say, hey, look, I'm not going to see the difference between the drops here, right? You may even just see a straight line of water going from the bag into the IV. All right. Now, what's going to happen with the maintenance fluids, right? That's an extra 60 milliliters there. So 1,660 milliliters an hour. She should be done with the first liter by 12:36 hours. So that's 12:36 p.m. And so she's going to be finished at 05:16 hours the next day. That's 5:16 in the morning. So once again, if you had trouble with any or all of that outside of the military time factor, you definitely want to revisit this factor label method. And I will be covering that once again in the next couple of slides. And once you get the idea, take a look at my timestamps down below to skip over, me just hitting that same idea multiple times. So I like to call this the phonics of math, or sounding out your math, right? And so let's look at this problem and kind of sound it out in a sense, right? And so we're trying to figure out what is going to be equal to what. And so we'll let you work on this, and then next slide will give you the answers. So Susie weighs 20 kilograms, and for every dose she gets, she is supposed to be getting 15 milligrams of Tylenol for every kilogram that she weighs. Alright, she gets one dose every 8 hours. Tylenol comes in a solution that has 160 milligrams of Tylenol for every 5 milliliters of solution. So take a second, pause the video, and when you think you have the answer, go to the next slide. So let's see how you did. So a couple of things to be aware of is when you say per, that's another way of saying divided by, right, or over. So for example, 60 miles per hour, right? We got 60 miles over top of hour, right? If I say $3 per gallon, right? Gas is $3 per gallon. I got $3 up top, and I got gallon on the bottom, right, of my fractions. All right. Okay, so another thing that we got is if they don't say a number, we're going to assume that number is 1. All right, so one patient is equal to 20 kilograms. How did you get that? Susie weighs 20 kilograms. Well, how many patients is Susie? She's one patient. So if I got one Susie, I got 20 kilograms. If I got 20 kilograms, I got one Susie in this case. All right, next thing that we got is supposed to be getting 15 milligrams of Tylenol per kilogram she weighs in every single dose that she gets, right? So how many doses is that? Or how many doses are we talking about? One dose is equal to 15 milligrams, right? And now she's getting that for every kilogram she weighs. So if she weighs more, she's getting more milligrams. If she weighs less, she's getting less milligrams. Now we can rearrange this, and we'll worry about this later. This is going to become important later. But one of the things you see is she's getting one dose every 8 hours, right? So if I want one dose, I need 8 hours. If it's been 8 hours, I'm getting another dose, right? And now this Tylenol comes in a solution that has 160 milligrams of Tylenol for every 5 milliliters of solution. So if I have 5 milliliters of the solution, I have 160 milligrams. If I have 160 milligrams, I have 5 milliliters of the solution. Okay, so let's see how you do on this slide right here. So Joanna weighs 44 pounds and is supposed to be getting 20 milliliters of IV fluid for every kilogram she weighs. If Joanna is supposed to get her IV fluids within 15 minutes, how fast should you set the IV for? Alright, and so the only thing I want you to do right here is once again determine what is equal to what. When you think you're ready, go to push play on the video and you'll see the answer. Okay, so once again, we look at this. Joanna weighs 44 pounds. Well, how much does our one patient weigh? 44 pounds, right? If I'm picking up a person that weighs 44 pounds, it's our one patient, right? If I have our one patient, they weigh 44 pounds. Now, you see right here, I have this thing highlighted in yellow. Why? Because that's not in the problem, and that's unfortunately something you'll have to memorize, right? If you learn to do your math this way, you're gonna still have to memorize a few things, but nowhere near as much, right? You're not gonna remember, oh crap, do I multiply when I'm changing kilograms to pounds, or do I divide? Oh man, I can never remember. Nope, the problem is going to tell you exactly what to do. The only thing that you need to know is what is equal to what, right? So 1 kilogram is equal to 2.2 pounds. All right, that's just something you're gonna have to memorize right there. Alright, so the next thing it's going to say is, in this problem, she's supposed to be getting 20 milliliters of IV fluids for every kilogram that she weighs. So, if you have 1 kilogram of Joanna in this case, you're going to get 20 milliliters of IV fluid, right? If she's getting 20 milliliters of IV fluid, it's because she weighs 1 kilogram. Alright, and so the total amount of IV fluids, if you want to know how long it takes her to do this whole IV fluids, it's going to take her 15 minutes. If she's been hooked up to her IV for 15 minutes, she's gotten all of her IV fluids. How do I know this? Because the problem tells me Joanna is supposed to get her IV fluids in 15 minutes. Alright, now the next thing you need to know is, your IVs are typically set in terms of milliliters per hour, right? And so the problem even asks for that, right? How many milliliters per hour should you set the IV for? Well, crap, I gotta know something else, right? And so you gotta know there's 60 minutes in an hour, right? If you have 1 hour, you got 60 minutes. If you have 60 minutes, you have 1 hour. On to our next question. If Joanna is supposed to be getting 1,600 milliliters an hour of IV fluids, right? And if there are 25 drops in a milliliter, how many drops per minute will her IV be running at? How much time will there be between drops? So take a minute to pause the video. When you think you have the answer, push play and see how you did. Alright, so here are the answers. So one of the things it's saying is 1,600 milliliters is equal to 1 hour, right? So 1 hour is equal to 1,600 milliliters. So she's been hooked up to this IV for 1 hour. She got 1,600 milliliters of IV fluid, right? Now they're saying there are 25 drops in a milliliter, right? That's what's called the drop factor, right? So if you count 25 drops, you just saw 1 milliliter go in. If you saw 1 milliliter go in, right, you saw 25 drops. All right. Now, once again, unfortunately in yellow, there are some things that you're just gonna have to memorize. Right, so there's 60 minutes an hour, all right? But the beauty of this thing is, well, Dr. Perkins, I'm having to memorize just as much either way. Well, no, right here, this is telling you that, hey, look, if you're going from hours to minutes, you multiply by 60, right? But if I'm going from minutes to hours, I divide by 60, right? You're going to see that later on, but the thing is, you're not having to remember, crap, do I multiply or divide? I don't remember. No, this tells you what to do later on. So hang tight and you will see. Anyways, 60 seconds is equal to 1 minute. So these are just some things, unfortunately, you will have to memorize. If Joanna is supposed to be getting 60 milliliters an hour, how long will it take her to finish a liter? So once again, pause the video, and when you think you know what's going on, hit play and see the answer. So one of the things the problem tells us is she's getting 60 milliliters 1 hour, right? So if you've waited an hour, she's gotten 60 milliliters. If she's gotten 60 milliliters, it's been an hour. All right. Now, unfortunately, once again, yellow are things that you're just going to have to know, right? You're going to need to know the metric system, so the meters, liters, grams, you know, what the milli, micro, and all that stuff means. That's a whole nother lecture for another day. But anyways, 1 liter is going to be equal to 1,000 milliliters. All right, and 60 minutes is going to be equal to 1 hour. So now, next step is how do you convert these equal statements into fractions? So for example, 44 pounds equals 1 patient. How am I going to turn that into a fraction? All right, pause the video when you think you know the answer. Go on to the next slide. So one of the things is you could say 44 pounds is over 1 patient, or 1 patient over 44 pounds. Either one's going to work just fine. All right, so how am I going to turn 1 kilogram equals 2.2 pounds into a fraction? Pause the video when you think you know the answer. Hit play and see if you got it right. So I could say 1 kilogram over 2.2 pounds, or I could say 2.2 pounds over 1 kilogram. All right, how do I turn 20 milliliters equals to 1 kilogram into a fraction? Pause the video when you think you know the answer, push play, see if you got it right. So I can put 20 milliliters over 1 kilogram, or 1 kilogram over 20 milliliters. All right, how on earth am I going to put how many milliliters of IV fluid is equal to 15 minutes? Pause the video when you think you know the answer, hit play, see how you did. So I could put however many milliliters of IV fluid over 15 minutes, or I could put 15 minutes over however many milliliters of IV fluid. All right, how am I going to change this into a fraction? Once again, you could put 60 minutes over an hour, or you could put 1 hour over 60 minutes. So why are we doing this? Well, what we're doing is we're creating a fancy one. The unit on top, the amount in the unit on top is going to be just as big as the amount in the unit on bottom, right? So I wrote 7 over 7, right? It doesn't look like 1, but it actually is 1, right? And so it doesn't matter if you write the word 7 out on top or if you write the word 7 out on the bottom, as long as what you have on top is just as big as what you have down bottom, it becomes a fancy 1, right? So it's like cars and tires, right? So let's say you have a parking lot that only has cars in it, right? 4 tires equals 1 car. 1 car equals 4 tires, right? That's a fancy 1. And so the beauty of this is it doesn't matter how many times you multiply 1 by itself, it's still equal to 1, right? So 1 times 1 is 1. It doesn't matter if I do 2 times or 27 times, it's still going to be equal to 1. And the beauty of that is, let's say your final answer looks like this. Crap. You know, I want this unit down bottom. You can literally just flip it because it's a fancy 1. And that's going to make your life a lot easier. So how do you multiply by fractions that don't have any labels on it, right? So give you a second, see if you can't figure it out. And if you think you have the answer, push play and we'll see how you did. Abracadabra, hocus pocus, let's bring this math problem into focus. All right, so a lot of students, oh, I know what to do, cross multiply. No, that's not how you multiply fractions. You multiply across, right? You don't multiply like this, wrong answer. You multiply like this, straight across. So 3 times 7, right, you're going to get a number up here. And then 4 times 8, you're going to get a number down here, right? The up top, we call that the numerator, right? The numbers up top. And the denominators are the numbers in the bottom, right here. And so we're going to keep those separate. And so what we're going to get is 21 over 38. So what we're going to do when we multiply by fractions is we want to set up our fractions in such a way that the unit in the numerator of one number is in the denominator of the other, right here. And so if we look at our fractions, we have bears above and below the fraction line. This thing right here is called the fraction line. All right, and so whenever that happens, our units are going to cancel. So here our units have canceled. Why? Because we have the same unit above and below the fraction line. Remember when I was telling you earlier how the problem tells you how to do it, right? That's the huge advantage, right? You're not having to remember, crap, do I divide by 16 or do I multiply by 16? No, look, this is telling you, look, you're going to multiply that top number by 16, and you're going to multiply that bottom number by 13. And so that makes your life really easy. So the answer you'd get for this mythical problem is 240 dogs over 156 cats. All right, and so what this problem would be saying is if you have 240 dogs, you have 156 cats. If you have 156 cats, you have 240 dogs. Now, we're not going to talk about simplification just yet. We'll hit that later on. So hang tight. But just remember, when you multiply fractions, you multiply straight across. So at this step, you should have 240 dogs over 156 cats. Alright guys, I'll give you a chance to see if you can't figure this one out. So you let me know what units cancel. Alright, so this is the units that canceled. So the answer should be 240 dogs over 156 cats. Alright, try this one. See what units cancel. Alright, this is the units that canceled. So the answer you should have gotten was 16 rabbits over 676 pencils. So once again, if you have 676 pencils, you have 16 rabbits. If you have 16 rabbits, you have 676 pencils. So what about a multi-step fraction? How are you going to cancel with that? The same way you've been canceling all along. If the same unit is above and below the fraction line, you're just going to cross it out. So hit pause, and when you're ready, hit play, and we'll see how you did. So here's the answer. So the answer you should have got is 33,488 rabbits over 172,380 zoos. Once again, if you have 172,380 zoos, you're going to have 33,488 rabbits. If you have 33,488 rabbits, you have 172,380 zoos, right? And once again, that's, assuming you made everything a fancy one all the way through, right? What's on top is going to be equal to what's down the bottom. All right, and so this is going to help us with our next step. So the last step is going to be simplify, right? So what is simplifying? So let's say that we have 9 rabbits for every 18 people. Well, that could be a little complicated, kind of try to calculate in your head and everything else, or to calculate on a pen, with pen and paper, or even kind of use with a calculator, right? It gives you more chance to mess things up. So what is the smallest amount of rabbits we can have for the smallest amount of people, right? And so what we're going to do is we're going to divide this bottom number by itself. So it goes back to one of the first things I said. Any number divided by itself is nothing more than a fancy 1, right? So 18 divided by itself is 1. So that's always going to give me 1. 1 what? Well, my unit tells me 1 person. Oh, okay, right? Well, guess what? If I just divide my bottom by 18, well, now I've created a lie. Why? Because there's not 9 rabbits for 1 person, right? There's 9 rabbits for 18 people. So I gotta do the same thing up top, but once again, any number, 18, divided by itself, 18 is nothing more than a fancy 1, right? This is a fancy 1. I'm not changing the ratio of rabbits to people right here. And so 9 divided that by 18 is 1/2, right? So I got a half of a rabbit per person right here, right? What about this over here? So I got 25 pandas for every 30 zoos, right? So if I have 30 zoos, I have 25 pandas. If I have 25 pandas, I have 30 zoos. Well, that's great, but I don't want to see all 30 zoos to know that I got that ratio, right? So one of the big things I'm going to do is I'm simplifying this thing, right? So 30, any number divided by itself is what? 1, right? Any number divided by itself is what? 1, right? This is a fancy 1. It doesn't look like a 1, but it is, right? Why? Because I'm not changing the ratio of pandas to zoos, right? Anyways, 25 divided that by 30 is going to be what? 0.833, right? And so that's how that works. Now, what if you're like, oh crap, I messed up. This is not what I'm trying to figure out. I want to know how many, how many zoos I need to see to see one panda. All right, well, go back to the previous thing that I said. So you know how, 7 over 7, it doesn't matter if you write out the words SEVEN over the Arabic numeral 7, right? You can flip that, right? Because pandas, 0.08 pandas is equal to 1 zoo, right? I could flip this. I could put the pandas down bottom and the zoos up top. And I could divide both sides by 0.833, right? And that would get me 1.2 zoos for every one panda, right? And so that really is the beauty of the math, is if you understand what you're doing, it makes it very hard to come up with the wrong answer if you understand what you're doing. So here's a problem that I did, not as a doctor, not as a medical student, not as part of any coursework, but as real life. All right, so just as a dad. So let me kind of give you the background of this problem. So my daughter, she was G-tube dependent, right? And her formula shipments were being messed up every single month. What do we mean by that? Well, we were getting the formula, but we kept running out of formula before the end of the month. And we were feeding my daughter exactly as the doctor said to do it, right? We were being ridiculously careful, and yet we're still coming up shy of formula. It's like, what the heck? I don't understand. It's like they're not giving us enough formula. So I got sick and tired of it, and I sat down and I calculated how much formula my daughter should be getting. And so this is all the information I needed to be able to figure it out, right? So 1 can of Elecare formula has 400 grams of formula in it. For every scoop of formula you use, that weighs 9.4 grams. You need 5 scoops of formula to make an 8-ounce bottle of formula. An 8-ounce bottle of formula has 216 calories in it. My daughter needs 100 calories for every kilogram she weighs every single day, right? My daughter weighs 13 kilograms at this point in time, right? And she should be gaining 0.2 kilograms of weight per month. Now, there are 30.5 days in an average month, and next month is April. How many cans of formula should she get each month for the next 6 months? And so I sat down and calculated this, and I'm going to show you that calculation, right? And it's going to be the exact same steps I was talking to you guys about earlier. Matter of fact, let's see if you can do it. So pause the video and see if you can't figure it out. All right. So now I just convert English into math, right? So I have 1 can of Elecare is equal to 400 grams of formula. 400 grams of formula is equal to 1 can of Elecare. 1 scoop of formula is equal to 9.4 grams. 9.4 grams of formula is equal to 1 scoop. 5 scoops of formula equals 8 ounces of liquid formula. 8 ounces of liquid formula equals 5 scoops. Alright, 8 ounces of liquid formula is equal to 216 calories. 216 calories is equal to 8 ounces of liquid formula. 100 calories is equal to 1 kilogram times 1 day. 1 kilogram times 1 day is equal to 100 calories. 1 kid is equal to 13 kilograms. 13 kilograms is equal to 1 kid. 0.2 kilograms equals weight gain per month. Weight gain per month equals 0.2 kilograms. 30.5 days equals 1 month. 1 month equals 30.5 days. And so you see how I can go back and forth. Why? Because I'm saying the same thing. They're a fancy one, right? And so the thing I'm trying to figure out is how many cans of formula does she need per month, right? So let's change this now into fraction form. Let's see how you do. So now I've created my fancy one. 1 can over 400 grams of formula, right? It doesn't matter if I put the 400 grams of formula up top or down bottom, it's still good, right? As long as what's up top is equal to what's down bottom, you're okay. But yeah, your fractions should all look like this. So now I've just got to think of how do I want to use these problems, right? And so the question that I have is how much formula should my daughter be getting per month? We'll just start off with the very simple one of next month, right? So, you could start anywhere as long as what you're doing makes sense, you're going to get to the right answer, right? As long as you don't tell any lies and you follow logical steps, you'll be okay. So you could start off with, hey, look, I know there are 30.5 days in a month. Well, that's great, but how much formula does she need? Well, in order to know that, I need to know how many calories she needs. Oh, okay. So this is going to tell me, help me convert my days into calories. Well, that's great, but I need to know how many kilograms the child weighs. Oh, then I'm going to use that. All right, now that I know how many calories I need, that's great, but I need to know how much formula I have. What links formula to calories? Oh, I need this right here. All right, so now I got liquid formula, but my formula is coming in this powder, coming in cans. How the heck am I going to figure this out? Okay, well, in order to be able to figure this out, here's my cans, but it comes in these grams, but I don't have a direct link here. Okay, well, I'm bringing it out through scoops. Okay, so yeah, this is the next thing I'm going to need to know, right? In order to go from here, right, I need to know how many scoops I'm going to need. All right, now that I know how many scoops I need, I know how many grams of formula I need. If I know how many grams of formula I need, I just figured out how many cans I have, right? I could have started off in the opposite direction, right? But as long as you have a path that makes sense, you'll be able to figure it out, right? I've had students that figure out how much, how many cans of formula she needs per day, and then figure out, okay, she needs this many cans of formula a day, then they figure out how many cans she'll need in a month. Just all sorts of different ways, right? There's no wrong way to do it, as long as you say, you follow logical steps, you'll be good. So I'll just do it one way, just for the sake of simplicity and stuff like that. And if you get the right answer, obviously you're doing it correctly. Now there is going to be some rounding. Now what I say about rounding is you want to wait till the last moment to round. Every time you round, you're going to throw your answer off by a little bit. So wait till the last step to round. So now I need to put these fractions in a logical order, right? And so what's really the beauty of this is you could start wherever, but as long as you're doing something that makes sense, you'll be good. So I picked, look, there are 30.5 days in a month, right? And so, well, that's great, but how much formula does my child need? Well, I know that the formula has energy in it, and so the energy is going to be in the form of calories. Okay, so she's going to need 100 calories per 1 kilogram that she weighs for every single day. All right, and so this is going to cancel. I got my days above and below the fraction line. That's going to cancel out, and so I figured out how many calories she needs per month for every kilogram that she weighs. Well, that's great, but how many calories is that? Well, in order to know that, I need to know how much this child weighs. And so I'm going to put 13 kilograms up top. Why? Because I want that to cancel with the kilograms down bottom, right? And so this is going to tell me how many calories per month for that one child she's going to get. Well, that's great, but they don't ship cans of Elecare in terms of calories, right? I'm not saying, hey, look, I need 17,000 calories worth of Elecare. Okay, here we go. Right? No, it doesn't work that way. And so I need to figure out how many cans of Elecare. All right, so what's going to be the next step that's going to help me with that? Well, I know there are 216 calories of calories in an 8-ounce formula bottle. So I'm going to put my calories down bottom. Why? Because that's going to cross out, right? My calories are above and below the fraction line. They're going to cancel. But that's going to leave me with 8 ounces of liquid formula. So this is going to tell me how many ounces of liquid formula I'm going to need per month, right? Per number of months. So that's great, but I want to know how many cans I'm going to get. Well, what's the next thing that's going to help me figure this out? Well, there's 5 scoops for 8 ounces of liquid formula. All right, and so guess what? I'm going to put my 8 ounces of liquid formula down here. Why? Because I got the same unit above and below the fraction line, so it's going to cancel. All right. Well, now I'm left with scoops per month, right? Scoops over months. Well, that's great, but once again, I'm not ordering scoops, I'm ordering cans. So what's going to help me figure this out? So right here, you see how I got this yellow highlighter? It's just because I ran out of space, right? I didn't have enough space to go all the way over here with my formula, right? I ran out of space. So anyways, what I got is I know there are 9.4 grams of formula per my 1 scoop of formula. All right. And so I'm going to put my 1 scoop down here. Why? Because I have scoops above and below my fraction line. So they're going to cancel out right here, right? And so now what I figured out is grams of formula over months. All right. And so now I'm going to put 1 can of Elecare over 400 grams. Well, how do I know that? Well, because I got grams both above and below the fraction line right here. And so these are going to cancel out. And so what I'm left with now is cans over months times kid, right? And so now what you're going to do is you're just going to multiply across, right? You're going to multiply the 30.5 times the 100 by the 13 by the 8 by the 5 by the 9.4 by 1, right? And that's going to give me a great big number for the numerator. Down bottom, for the denominator, the bottom number, I'm going to do 1 times 1 times 1 times 1 times 216 by 8 by 1 by 400. And I'm going to get a great big number down bottom. All right, and so what I'm going to need to do on the next side is simplify. So when I multiplied all the numbers, I got that there were 14,908,400 cans of formula that my daughter would need over 691,200 months. Well, that's great to know that, but I'm not interested in 691,200 months. I just want to know about next month. How much formula will my daughter need, right? And so that's the problem. So how do I go from 691,200 months down to 1 month? Well, if I subtract 691,199 months, that's great, but how much formula is equal to that? Yeah, there's kind of a problem there, right? So you can't quite do that. So what you're going to do is you're going to divide both sides by 691,200, and let's see what we got. And so what you get is you get 21.56 cans per 1 month per 1 child, right? Now that's the math answer. Now here's the thing: as a nurse, as a doctor, right, we don't just calculate things for the heck of calculating things. We're trying to do something with this, right? And so if you were to round this mathematically, you're going to round this to 22 cans, right? As a nurse or a dad or whatever, right, what are you trying to do, right? If you don't want to have any more than the absolute minimal that you need, right, you might, you can't have any more than that number of cans, then you need to round down to 21. If you don't want to have any less than that amount of cans, then you need to round up, right? And just that is how this process is done. And so you see, I'm just doing the same steps over and over and over and over again. This is a fairly complicated problem. It had a multi-steps, but yet I did the exact same thing that you'd use for fluids, milliliters, or whatever. So if you need more examples, let me know. All right, that concludes today's episode. If you liked what you heard, be sure to click the subscribe and like button down below. And as always, if you have any questions, comments, concerns, or if there's any particular topic you'd like me to create a video on, let me know in the comments down below. All right, well, I look forward to seeing you on my next podcast.